All right. So in this example that I'm doing, this is from exercise 6F, question 2. Thank you, team. Eyes and ears towards the board. Shh. Explanation for when they say draw a sign diagram. Let's take a first one. Let's do an easy one. Let's have a look at this function here. So, I taught you an intuitive way to look at an equation so that you can predict what it looks like and then you can sketch. When you're doing the exams, especially for mid-year exams and next year, sometimes you can't explain intuition on paper. So when they ask you to show that or justify your responses, how you know there's a maximum here and a minimum there, a sign diagram is one of the techniques we use to prove that a graph looks the way it does. And examples like this one, which I picked out an easier one, if we were to predict this graph, we know it's cubic because the highest power is 3. Now cubics can look like an N shape, or it could be the reverse N shape. So the difference is you either get a maximum, meaning it reaches a top point before you get to a minimum and then it curves back up, or you have a minimum that occurs back up as a maximum and it goes all the way down. So when we work out this graph, we can do x-intercepts and y-intercepts here, right? So I can do y-intercept. What's the y-intercept in this case? What do you let again? Let x equal to 0. So here you say let x equal to 0. We're trying to find y. So y will equal to 0 cubed minus 9 times 0. That gives me a y-intercept of 0. So that means at 0, 0, I've got a y-intercept, right? So if I were to draw the graph here, just on the side, let's just do a quick graph to visualize. Let's do it like this. I've got now this point, 0, 0, on the y-axis. Then if I ask you to find the x-intercept, to find the x-intercept, you let, what do? Y equal to 0. So you don't know what x is, but you know the y coordinate 0. So that means your equation is 0 is equal to x cubed minus 9x. Now conveniently, this is easier to do. That's why I picked this one. You can't solve it when you have two x's. So one of the techniques we do is we learn to factorize. What you've been doing in 6b, c, and d is to factorize when you have a full cubic equation. This is not a full cubic equation. This does have something that we can factorize together. What's common about the two terms? They both have an x. So I can factorize it now without using any factor theorem, remainder theorem. I can just say, well, they both have an x. That means it becomes x squared minus 9 because x times x squared gives you x cubed and x times negative 9 gives you negative 9x. Yeah? So I've factorized it. Why is this good? It's because now I've got a quadratic factor. That's my linear factor over there. I can factorize x squared minus 9. Testing your memory. DOPS. What does that give me? What's x squared minus 9 the same as? What was that? X plus 3 and? Beautiful. Difference of perfect squares. So something squared minus, and you can write that as a 3 squared. So hence x plus 3 or x minus 3. So here's my 3 brackets. Even though it doesn't look like a bracket over here, technically you've got 3 brackets. Cubics should have 3 intercepts maximum. So in this case here, it looks like my x-intercepts are at x equals 0 or negative 3 or 3. So if I go back to this point here over here, if I put all the x-intercepts in, you get 3 and you got negative 3. Now here's the question. Does the graph go up, down, and across? Whoops. So does it look like that? Because it crosses through 3. Or does it look like that? Because it crosses through 3 as well. Now obviously I taught you a way to read the equation so we know which one it should be. Now let's read the equation again. Positive x cubed, so which one should it be? The pink one or the green one? Oh, you don't know actually. Hands up for pink. Hands up for green. Okay, well, and then hands up if you don't know. Okay, cool. The answer is pink. And the way I taught you guys, I said, when the number in front of x cubed, which is the coefficient, the number's 1, but it's positive 1. And we know that a cubic graph, when it's positive, it means that as you go to the right, it keeps going up. That's when you have a positive cube. If you have a negative, negative is the other way around. As you go further to the right, it actually goes down. The graph goes down. And that is typical of a negative x cubed, right? But that there is my intuition, and that's something I taught you to sort of learn by reading an equation. If this wasn't an exam and they said, justify that you have a maximum at whatever this point is, how do you prove that it actually looks like the red line? Especially if you didn't know how to read. So let's say you did, prior to this lesson, you did not know this. I never taught you this. How would you know that? Because usually we rely on the y-intercept to tell us whether it's up or down, but the y-intercept and the x-intercept are the same. So that makes it hard to tell whether it's green or the red line. This is where you use the sign diagram. The sign diagram is tedious. I hate doing it, but it is one of our tools to sort of justify our reasoning. So this is what it is. Sign diagram takes this picture and puts it into a plane. So this is what they do. They draw a line. That's your x-axis. So they don't care about the full graph. They say, all right, so you got x-intercept at -3, you got 0, you got 3. True? This line represents your x-axis, and we know that -3, 0, and 3 were your x-intercepts. That's when y equals 0, right? So it has to cross through them. So what they do is they label this top as positive, negative. That's why it's called a sign diagram. And all you have to do is you now test numbers to see if I picked a number less than -3. So pick a number that's less than -3. What's less than -3? -4. Yeah, I'll pick a whole number rather than a fractional number. So I do -4. And what you have to do now is you have to test. Well, what's the sign? If x equals -4, then your y equation, remember it was x cubed minus 9x, then it now becomes -4 cubed minus 9 times -4. Now you don't need to know the value. You just need to know the sign. Is this going to be a negative answer or a positive answer? Negative, because logic is cube of a negative is going to be a negative. So I can already see this is going to be a negative value. And then over here, a negative and a negative, well, that technically is a positive. But the comparison is 4 cubed versus 9 times 4. Which one's bigger? And clearly, 4 cubing it is going to be much larger than whatever 9 times 4 can be. So I know the overall answer is going to be a negative value. Okay, so the negative value, if you wanted to calculate it, you would have done -64 plus 36. And that gives you what? Negative, anyone got some quick maths there? What's that? 34 take away 6 is 28? Is that right? -28. What you do is then you say, all right, that means in this region, when you picked a number that's less than -3, you draw a line to say it's in the negative region. What do you do once you get to -3? Well, then you draw a vertical line because that touches at 0. Then you test, okay, so it's negative. Then you test, well, let's pick a number between -3 and 0. What's the number you're going to pick? Remember, make your life easier. Which number is best between -3 and 0? -2 works, but I think a better answer is, yeah, -1. -1 is between -3 and 0. I picked -1 because it's easier to sub in. So then I would then say, all right, well, let's do it again. We then say, all right, if x was equal to -1, y will equal to -1 cubed minus 9 times -1. In this case, we can see -1 cubed is -1 plus 9. Get a positive 8. So what does that mean? It means that any number between, pretty much our prediction is that the signs for whatever number you pick here is going to be positive. Because here's 0, here's negative. So that means if this is 0 and that's 0, then it depends, you're either positive or negative. It can't be, well, you could be 0 all the way, but then you would have these as your x-intercepts. Yeah, so this is already the 0 mark. You're either positive or you're either negative. So if I picked a number and it tells me it's positive, I can tell all of these up here are now positive because I picked out -1. See what I'm doing there? So -1 gave me positive, -4 gave me negative. Now if you join them, can you see how we're getting this shape? That tells me it's a maximum. Can you see how it looks like a maximum shape there? So now it means if you pick 0 to 3, if you picked another number, what number would you pick? Between 0 and 3, what's the most logical number? 1. So if I picked 1, here's my sign diagram, x equals 1, y equals to 1 cubed minus 9 times 1, and you get 1, take away 9, clearly becomes negative, and then you start to pick up a pattern here. You can probably already predict, but because it's a justify problem, you actually have to show, you actually have to test another number. That's why it's tedious. And this is why learning to do function notation would have saved you time from writing something like that. You could have wrote f of -4, and then you write out the answer, which is -28. That would have been equivalent if you define the function. But this is called a sign diagram. So this gives you this visual idea that the graph must go maximum, minimum, and it stays in a positive region. See how it keeps going up? Because that means for all these numbers here, it's always going to be positive. That's why I know it's a max, min, up. And that's how you know which type of graph you should then pick. So we look back up here. It clearly cannot be the green. That one represents this one. So that's called a sign diagram. You use it in year 12 not to do this bit, but when you do derivatives. So when you start doing calculus and graphs, we use sign diagram to talk about gradients rather than the y values. Okay, so that's why I taught you to understand the equations just quicker than doing that. But if they ask you to justify or show, you do have to do it this way. It's a pain, but they'll give you space. They'll give you space to do it. Especially in year 11 exams, you often do more sign diagrams, but once you get to year 12, we don't usually do this because it takes too long to do. No, that's good, yeah. So if I were to get this in exam, yeah, I would have quickly changed this one. I would have said, let f of x equal to y, which equals to x cubed minus 9 of x. By saying that, I'm essentially now saying I'm going to define it as a function. So in the next few tests, I would then do f of -1, f of -4, and then I would sub it in. Okay, so that would just be quicker than you writing what I wrote here, where you say, let x equals this, y equals that. Just like writing this here is sufficient enough. And in year 12, that's how they do it. So they'll write 4 different statements. They'll do f of something equals that, f of something equals that, f of this equals that, and then they make a therefore statement. Okay. So I just thought I'd clarify that bit in case you're working with sign diagrams. It's a pain. Don't do it all the time. Do it so that you know how to use it, and then move on. Cool? But hopefully up to this point, most of us now know how to use polynomial division, factor theorem, remainder theorem, how to solve, how to sketch. That's 6B to F. That's your core foundation. Cool? All right, I'm going to stop the video here. Now we're going to